This enhancement significantly improves integrated simulation and verification performance by providing more accurate collision detection and more reliable collision reporting. It includes aligned collision checking between ISV and manufacturing, precise detection for tool, IPW, and tool part interactions, and the elimination of false collisions for non-spinning tools. As a result, no unwanted gouge detection occurs during deburring in ISV. In this video, we will demonstrate collision check quality improvements using 3 different examples. Let's begin with the simulation of a probing operation. Select the operation and choose Simulate Machine from the Home ribbon. Then activate Material Removal in the IPW section and Tool IPW in the Collision section. Here, you can see the behavior before and after the enhancement. Previously, no collision between the tool and the IPW was detected. Now, the collision is highlighted in the graphics window and documented in the Details panel. Next, let's look at the simulation of a drilling operation. For this example, make sure machine collision detection is enabled. In the simulation settings, you can define collision pairs. In this case, we will check for collisions between all inactive tools and the part. Once again, the difference before and after the enhancement is clear. Without the enhancement, a false collision is reported between the cutting geometry of the tool and the workpiece. This happens because the spindle stops in the middle of the operation, causing the tool to be classified as inactive. With the new quality improvements, this false detection no longer occurs. Finally, let's review gouge detection in a planar deburring operation. First, we will check the tool path with the checking options set as shown. As you can see, there are no collision findings, which is the correct result. Next, for the machine simulation, enable Material Removal, Tool Part Collision Detection, and Tool IPW Collision Detection. Without the enhancement, a collision is detected because the part is being gouged. However, in a deburring operation, this gouge is intentional. The enhanced behavior therefore aligns better with the expected simulation result and with the previous tool path check. Overall, the improved alignment between ONT and ISV, supported by consistent gouge identification, creates a more predictable and dependable workflow.